distinguish these two x's from each other. It
Yeah.
doesn't matter which is your 2 and which is your 1, as long as you don't switch the pairs. We can't call this x1, y2 because they're part of the same coordinate, okay?
Yeah.
We would get the exact same answer if we called this x1, y1 and this x2, y2. So the only point of the subscript is to keep the orders the same.
But then when you like subtract it, how do you know which axis it is? It's the x-axis if it's the x's, right?
Oh, yes. When you're looking at x2, it's the one you've labeled x2.
Okay.
Yep. And so are you asking for the connection between here and here? Yes. So if you're looking at the one that's horizontal, that's always going to be the change in x values. Because if you think about it, your x-axis is always going this way. You're looking for the vertical one, that's going to be the change in y's, because y is the one that changes up and down. Okay. So has everyone finished number 1?
Yeah.
What do we get?
Square root of 13.
Everyone got square root of 13?
Yep.
Awesome.
Almost.
Okay.
Yeah.
Wait,
All right.
What's 11 squared is 121, right?
Yeah.
11 squared is 121. So which one are you on now? Are you guys on 2?
Oh, I skipped 2. I did 3.
Some are doing 2 and some are doing 3? Okay. Take another minute or so, and then I want us to all try 4. So once you feel like we're good, then we'll move on to 4, because 4 is a little different. Wait, what are you saying?
Four has big numbers.
Ooh, how interesting. So what problem does that present?
Whether to do
You can't
the
graph it.
difference between the two methods.
Yeah. So what are you finding right now?
Well, I did like the triangle way for the first one. I decided to do the distance formula for this one.
Yeah, why does it make sense to use the distance formula in that case?
Because you don't want
Oh, you
to
don't
draw
have to
graph it.
Bingo.
But
Okay.
this square root of
Once you have done the triangle method 3 times, it's tempting to say, I don't need the distance formula anymore, right? I put number 4 in here to remind you guys that the distance formula still has its value.
What is 37 squared?
What is 37 squared? Why don't you take out your calculator?
Okay, cool.
Calculate.
I like that.
I'm not a big fan of math for math's sake. I want it to be for the sake of understanding the lesson. So I don't need you guys to do everything out by hand. That's not the point. I want you to get it. Is everyone trying 4 now?
Yeah.
Good. It's okay. Let's kind of go line by line, make sure we got to the same points. Did you guys get something like negative 14 squared?
Yeah.
Or positive 14 squared? Because it's going to ultimately yield you the same answer. And then negative 20 minus 1. Did you get you about negative 21?
What?
Wait, negative 20 minus 7.
Oh, sorry, minus 17, thank you. Caught my error. Good job. So then you get something like negative 37, right? And that's where you're squaring at 37?
Yeah.
Perfect. Good?
Oh,
It's negative 37 squared.
1369.
That's 1369, good.
14 squared.
So.
You guys tell me, you're the ones with the calculator.
I'm like trying to figure it.
1565.
Oh, you do like the tree thing?
What's the tree thing?
You like break it.
Oh, no.
Break. I don't know. You like break it apart and then you find
There's
the
an easy
factors.
We don't need to.
Okay.
Just square 14. Well, what do you guys get when you square
Wait.
14?
Square 14.
I'm close.
196.
Good, 196. Excellent.
And then
So now we're just going to add 196 and then that 1369 together. And what do we get?
1565.
1565. Okay. And we're going to just throw that under a radical. Okay.
Yeah.
We could check to see if any perfect squares go in, and we can see if we can simplify that radical. However, our answer right now is still correct.
Okay.
Okay? So if you guys are good, I'm happy with leaving it potentially unsimplified for the sake of time. Okay?
Okay.
Sound good?
That's good.
Awesome. Let's go on to the next page. Okay. We've already pretty much hit on a lot of this, but I kind of want to use this as a chance to review. Okay? Camera's on, right? Perfect. Okay, so when does it make sense to use the distance formula?
When you can't graph.
When you have like really big numbers.
When you've got really big numbers and that's hard to graph. Okay, so we're just going to say big numbers. Now, what's a strategy you could use If you still want to graph, but you've got big numbers, what might you do as a strategy?
Maybe make the scale shorter.
Change your scale. Okay, so there are ways to go around it, but when you're dealing with really strange, perhaps prime numbers, okay, that you can't subdivide further, it often makes sense to use the distance formula. Okay? Now, when would it make sense to use the Pythagorean theorem and visualize that on the coordinate plane?
When you're actually able to put it on the graph.
Yeah, so what kind of numbers would you be dealing with?
Small numbers.
Oh, like
Smaller
under,
numbers.
under 20.
Smaller numbers that.
Under 20?
Yeah.
We had
Or under
17 and
10.
that was kind of ugly.
Yeah, so maybe
Under
under
10.
12.
Under 10.
Yeah, I would say like under 10. I think
Under
10 is
10.
a good number. So we'll say numbers under 10. Good. Now we went over this, but I want you to take the chance now to say it in your own words. Okay, so take a moment just to think about it for about 10 seconds, and then we'll go over it together. Part A. Who wants to read it out loud?
I will.
Go ahead.
What does the x2 minus x1 represent? Why do you need to subtract the two x values as opposed to add them?
Good. Take a moment, think about it. If you want to jot down your own answer in your own words, we'll go over it in about 5 seconds. All right, Spencer, what do you think on that one?
The difference between two x values.
Mm-hmm. So what does that represent visually?
How much the point moves on the x-axis.
Good. Not quite on the
Yeah,
x-axis,
yeah,
but
but
parallel to it?
Yeah.
Exactly. Good. So we would call that the
Not
horizontal,
the x-axis, yeah.
the horizontal change,
Mhm.
right? Let's talk about it in terms of right triangle vocabulary. Would that be the base, the height, or the hypotenuse?
Base.
Good. Good. Now, part B. I'm not going to give you guys think time because I think you can do this. What does the y2 minus y1 represent? Why do you need to subtract the two y values as opposed to add them? So, Courtney, try this one.
So it's the vertical change.
Good. Vertical change.
And you need to subtract them because you're trying to find the difference between them.
Perfect. Okay. And now, if you were using right triangle vocabulary, what would you call that vertical change?
Would be the height.
Perfect. Okay. Now I'm going to give you some think time. Okay, so Summer, why don't you read this one out loud?
Okay. The C?
Mm-hmm.
Okay. Why does each difference get squared and then added together? Where did these operations originate from? Be explicit.
Okay. So if you want, I'll show you a little bit more about what that means. Basically, I'm saying we've got the difference in the x values, and we've got the difference in the y values. Does everyone see these two differences? So my question is, why then am I going to add them and square them? Okay, why am I going to square each individual one and then add it? Where did that come from?
Because the C in the end, in Pythagorean theorem, it's square, so you have to square root that. So like the big square root in the difference.
Be careful, we're not doing the big square root yet. The big square root is actually going to be part D.
Oh.
So hold that thought because you're right, just not yet. I'm isolating this part of the formula, okay? We already know why these two things are here. This tells us the base, this tells us the height, okay? Now, why am I going to square those values and add them together? Where have you seen something that looks like this? Something squared plus something squared.
Yeah.
Oh.
It's
What is it
because
called?
it's the length of each of the sides that isn't the hypotenuse.
Good, what do we call those things that aren't the hypotenuse?
Legs.
Good, each of these are the legs. So, what does the Pythagorean theorem state? That what squared plus what squared?
The legs.
A squared plus b squared, or the sum of the squares of the legs. Either one's correct. So you want to think of this as essentially a squared plus b squared. That's where that plus comes from, and that's where those squares come from. So far, so good? Now, part D, Charlene, read it.
Why is the entire formula underneath a square root symbol? Where did that square root originate from?
Okay. I think you guys can handle this, so let me have Amelia try it.
It's to like.
State for me the Pythagorean theorem.
A squared plus b squared equals c squared.
A squared plus B squared equals C squared. What value are you trying to find? A, B, or C?
We're trying to find C, but C is squared. You put the square root at the beginning so you don't have to deal with it later.
Perfect. You're undoing that operation from the get-go. Sound good? Okay, so that's really coming from this right here. And that's where you get that square root of A squared plus B squared. Okay, so now take a moment in. You have a back, right?
Yes, ma'am.
Before you get to the back, go back to your third page. Okay? In the top corner, I just want you to practice. Write the distance formula just once. Okay? Okay. Does anyone have a question about their distance formula? Can I have one person just read it out? Okay, go ahead. So everyone just try.
The square root of x squared minus x1 squared plus y squared minus y1 squared.
Y squared.
y2 minus y1.
Good.
x2 minus
Quantity squared. Okay? Everybody got that?
Yeah.
Good. Okay. Now I want you to try this by yourselves. So no help from your neighbor, no help from me. Okay? This is a chance to see how well you got it. Okay? You can see the graph that's given to you. Okay? A says find the distance from A to D using the Pythagorean theorem. Now, part B asks you to use the distance formula, so please follow directions carefully. You're going to use one method for A, one method for B, and then C and D are going to be kind of reflection and thoughtful questions. Okay? So I think we're good now.